Welcome to the Explainer. So if you've touched Python at all, you've definitely used a list. They're everywhere. But what if the data you're working with absolutely cannot change? Or what if you need to find stuff by a name, not just a number in a line? Well, today we're going to crack open two super powerful data structures that handle exactly that, tuples and dictionaries. Let's get into it. Okay, so let's start with a really common problem. Picture this. You've got some super important data in your code, right? Maybe it's coordinates for a map or some key settings for your app. How in the world do you protect that stuff from being accidentally changed somewhere else? It's a huge deal.
So here's what we're covering today. First, we'll see why lists sometimes fall short. Then we'll meet our heroes, tuples and dictionaries. After that, we'll see them in action and wrap up with a quick guide on when to use which.
All right, so lists, we all use them, we all love them. They're ordered, you can access things by their position, and you can change them up whenever you feel like it. But that flexibility, that mutability, that can actually be a huge problem when you need your data to be totally solid and predictable. And that brings us to our first answer, the tuple. Honestly, the best way to think about a tuple is like a list that's been set in concrete. It is your go-to, your secret weapon for any data that cannot, and I mean cannot, ever change. The magic word here is immutability. Yeah, a tuple is an ordered collection, just like a list. But the second you create it, bam, it's locked down. You can't add to it, you can't take away from it, you can't change anything inside it. And you know what? That's not a bug, it's a feature. It's a guarantee that your data stays safe. And you want to know the crazy part? Look how simple the difference is in the code. It literally comes down to one character. Square brackets, you get a list you can mess with. Parentheses, you get a tuple that's locked tight. Just by switching from brackets to parentheses, you're telling Python and any other developer, hey, this data is important. Don't touch. Now, don't think that immutable means hard to use. Not at all. Reading data from a tuple? It's exactly the same as a list. You just use those same old square brackets with an index number to pull out whatever you need. Super simple, super familiar. Okay, but here it is, the moment of truth. This is where the tuple really proves its worth. We're going to take that tuple and we're going to try to break the rules. We're going to try to change that first element from a 1 to a 5. So what happens next? Bam! Type error. Python itself slams on the brakes and says, nope, you can't do that. It's like a built-in security guard for your data. And remember, this isn't an error in a bad way. It's the tuple doing its job perfectly, enforcing that do not change rule we wanted. So when would you actually use this? Oh, all the time. Think about it. Data that just belongs together and should never change. Like coordinates on a map, right? It's always an X and a Y. Or RGB color codes, always 3 numbers. A tuple is the perfect secure little box for that kind of information. Okay, so tuples are awesome for protecting data. Problem solved. But what if your issue isn't about order and numbers? What if you need to find information by a name or a unique ID? Well, that's where the dictionary comes in. And trust me, this is a total game changer. Forget numbered positions. A dictionary stores everything in key value pairs. You have a unique key, like a word, that you use to look up its value, like its definition. It's basically a real-world dictionary, but for your data. And you can see that structure right here. On the left, you've got your keys, these nice descriptive labels like name or age. And on the right, you've got the actual data, the values. No more scratching your head wondering, what was a position 0 again? The key tells you exactly what you're looking at. This is super powerful, but there is one little trap you can fall into. If you try to look up a key that doesn't exist, say minor for a student who doesn't have one, your whole program can come crashing down with something called a key error. Yikes. But thankfully, there's a much safer way to do it. And this is it, the get method. Seriously, this is the pro move. When you use get to look for a key that isn't there, does your program crash? Nope. It just politely gives you back none. And what's even cooler is you can give it a default value, like undeclared, to use instead. It's so much safer and just cleaner. Now, here's where dictionaries are the complete opposite of tuples. Dictionaries are totally changeable. They're meant to be dynamic. You can add new stuff, update old stuff, delete stuff you don't need anymore, whatever. This makes them perfect for data that needs to grow and change as your program runs. All right, enough theory. Let's see how these things actually work in the real world. So let's say you're building an inventory system. A dictionary is your best friend here. You'd use the product's unique ID as the key, right? That means you can grab all the info for any product instantly. A sale comes through? No problem. You just look up the ID and change the stock number. So fast, so easy. Or how about user settings in an app? Perfect for a dictionary. The key is the name of the setting, like theme, and the value is the user's choice, like dark. And check this out. You can mix and match. Maybe the window_size setting should never change. You can just store that as a tuple inside your dictionary. You get the best of both worlds. Okay, so we've seen they're both super useful. The big question is, how do you decide which one to use? Let's break it down.
This is it, your cheat sheet. Need an ordered list of things that you're going to change a lot? Use a list. Got an unordered list of things that should never change? Use a tuple. And if you need to store and find data using labels or names, not numbers, that's a job for a dictionary. That's really all there is to it.
So, I'm going to leave you with this question. You're starting your next big project, and you have to store some user settings. Which data structure are you going to reach for, and more importantly, why? Thinking about these things, does it need to change? How will I find it? That's what separates good code from great code. Choosing the right tool for the job is everything.